Okay, so hi everyone. In this server at least, so do you remember the Hydra? The Hydra thing. Okay, so this video, it was for the server. And this guy, okay, he thinks that the Hydra roll challenge is impossible. Well, only because he can't understand me. I'm not speaking cursive, okay? I'm not. Seriously, I'm not. What do you mean I'm speaking cursive? Okay, anyways, hold up, I'm gonna freaking watch a script now, so I can keep track of rules. Yep, you should do that. Maybe I should do that too, so everyone can keep track of rules, but yeah. Anyways, I'm taking notes. Okay. And a bit later he's like, okay, decipher the first few minutes, the simple ones. Okay, where... Oh, and here it comes. Oh god, this is insane. N equals the number of attempts. And it is the multiplier. So the more cuts you do it, the more it multiplies. I've heard of this problem before though. I don't think you have. Well, you probably have, but if you had, then you would know how big this is. Come on. Isn't it technically 100%? Even if you make mistakes, there are no mistakes. What mistakes? There's no mistakes. There's one thing you can do. I mean, there's several cuts you can make, but I told you to make the rightmost cut, so there's no mistakes. So, okay. He has the examples here. So he literally gives you a step-by-step guide. Yes, it isn't hard. It isn't hard to understand the rules, I told you. But I'm naming this man, he's too busy playing Osu or something. No, I'm not playing Osu, this has been here for days. I opened it like 5 minutes and it stayed there for some reason. But anyway, and here it comes. I don't want to spend the next 15 minutes drawing lines and circles. So I'm going to tell you how big this is. Okay, so this is a program in Java that acts exactly like the Hydra. Okay, so here's one node. Okay, that's the same. Here's two nodes. Okay, and the step number is the n. Okay, I'm going to go with 3 nodes. And as you can see, it's exactly the same. For this, it's 4 for 3 nodes. For 4 nodes, it's wait, like that, and it will be 38. And one thing, I told you to do the rightmost one, but here it's easier to do the leftmost one because well, it's the same. Okay, it's the same, but as you can see, it's the same, but it's easier to do here because otherwise I would have to do this and move the mouse. Here I can just keep it in place. Okay, so that's for 4, it's 38. And how about 5? I'm going to show you how brutally insane this is. Okay, here it comes. So I'm going to do the first. I'm just going to reduce it until something is connected to this, until I can cut one that is connected to this, okay? So here it comes. And that's it. Now these don't generate any copies, as you can see. And yeah, that was impressive, wasn't it? Let's go back a bit. And yeah, so you see this. This is even bigger than it looks, actually. So that was pretty bad. This looks pretty fucking bad. This looks pretty massive, but I'm going to explain exactly how massive it is. And this is just like 5 nodes. You can do 10 if you want, and it will be much worse. Okay, so here it comes. These nodes add 1, as you can see. And here's the thing. I have 76 here, right? So if I click one of these, they will multiply these, right? Okay, let me either click. They will make 76 copies of that. And now I have twice as many copies. Well, now then it's twice as big. So each one of these guys, multiply n by 2. And now guess what? If when I okay, this one multiplies n by 2, this one multiplies n by 2, etc. This is like multiplying by 2 to the 1, 2, 3, 4, as many as there are here. So here's the fun thing. These make it grow exponentially. These guys, like the second smallest guys, make it grow exponentially. Each one of these. So, and when I get rid of all of these, I get to one of these. And how many copies will I make of these guys? With one of these? As many as I have of n here. So this means that n will become 2 to the n. So what does this mean? Okay, so if each one of these multiplies by 2, this makes it 2 to the n. Well, more exactly, n times 2 to the n. Kinda. Yeah. But still, 2 to the n. So by solving this, I make it 2 to the n. And by solving this one, I make 2 to the n. I mean the current n I'm here. Well, actually it would add another 2 to the, because I have to solve all of these, which were one of these before. So each one of these makes it grow exponentially. And this will make n copies of these. So what does this do? Okay, so go search Knuth's arrow notation. Knuth arrow notation, okay. Like this. Maybe for the explanation of Graham's number. And you will see that this makes iterated exponentiation by making copies of these. So this makes it 2 arrows, which is iteration. So with 3 nodes here, it will be 2 arrows. With 4, it will be 3 arrows, etc. So the more there are, I think one node here adds 1 arrow. So this is already massive at this point. This is like not even close to anything you can do. And here, but here comes more fun stuff. These make these guys, but they make it like, how many nodes will there be here? As big, well, as many as n. They will make n nodes here. So this is like making n arrows. So what does this mean? It means that in the fast growing hierarchy, which you will need to understand for this, these guys, these tiny looking guys, fall here in omega, in f of omega of n. These guys, by cutting this, make n copies of these. So this is omega plus 1. This is omega plus 2, omega plus 3, etc, etc. 1, 2, 3, 4, 5, 6, 7, 8. Omega plus 8. And this is, well, this is the same. This will make n copies here. So omega plus n, which is omega plus omega. So omega 2. It's omega 2 plus 1, omega 2 plus 2, and omega 2 plus 3 here. So, well, all of these together will make like omega 2 plus 4, because, well, these come from something that would be like omega 2 plus 4. So yeah, this is like here, omega 2 but plus 4. And guess what? This is like from that, from, where was it? Where was it? Come on. Here. So you see where it comes from. So omega 2 plus 4, which was an omega 3 in the previous step, by the way. But this is like 5 nodes. So let me get more. Let me get 6 nodes to show you how fast it grows. Okay, so I can't. Okay, I can't pause. So play. No, start with 6 nodes. So let me get the next Hydra, which would be 6 nodes. And I have never done this one to the point where you can start cutting without copies. So I don't know what will happen, but let me tell you one thing. Like, as you add more nodes to the Hydra, and you make it taller, it will fall here. It will start falling here. So yeah, that's pretty impressive. That's actually massive, like insanely, absolutely, utterly massive. Okay, let me find this Hydra. I wish I could just make it myself, but I can't. Okay, so has to be randomized. I'm sorry for this. Come on, where is it? Come on. Fuck. Screw it. Okay, you know what? I'll make 50. I'll make 50 and try to find a 6. And this. Okay, this isn't helping. I'm really sorry. Just skip in the video. Skip further to where I start having like a ton of nodes. Okay, it's here. So let's do this. This is going to be really fun. Oh yeah, it is. Okay, so now we have this. And check this out. This is going to be really fun. Okay, so now. Okay. Here. And this is where I got here, but now this makes copies. This actually makes copies. Now, look at this. There are 1 million nodes here. Oh my god. This is now, all of that is copies of that. And you know what? Solving the previous Hydra, all that would do would just be reducing all of this and making more copies, making that, all of that would just be copies until I get to the last few where it's all just these, because I would have to get rid of all of these for this copy, and God knows how many there are. And just to get to the point where you can finally remove them without making copies. So look at this Hydra, it's lagging so bad. I need to restart this. It's lagging so bad. So yeah, the Hydra is unbeatable. Get wrecked.